Welcome to Demystifying Math. In this lesson, we're going to be going over some of the properties of logs. Let's start off with the product property. If you have the log of a product, you can rewrite it as the sum of two logs. We're going to do a proof to show you that that works. We're going to let m equal log base a of x and n equal log base a of y. Then we're going to rewrite each one of those exponentially. So a to the m equals x is equivalent to m equals log base a of x. And for the second one, we have a to the n equals y. If I want to multiply x times y, I would get a to the m times a to the n. And simplifying that, I would add those exponents. So I have a to the m plus n. Now, changing that back into log form, we have log base a of xy is equal to m plus n. Remember that when you're dealing with logs, you're really dealing with the exponents. So by substitution, we have log base a of xy is equal to m, which is log base a of x, plus n, which is log base a of y. So we get the product property. Let's put this to use. Let's suppose we had log base 10 of 10 squared times 10 cubed. By the property, that would be equal to log base 10 of 10 squared plus log base 10 of 10 cubed. Let's check both sides. If you have 10 squared times 10 to the third, you would add the exponents and get 10 to the fifth. Then we're going to evaluate log base 10 of 10 to the fifth. Well, of course that's 5. And on the other side, we have log base 10 of 10 squared, which is just going to be 2. As long as your exponent and your base are the same, your bases are the same, then you're going to just use whatever is in the exponent. So for log base 10 of 10 to the third, you get 3. So both sides are equal to 5. So you can see that this property is working. For something that has a variable in it, you want to expand the logs. So in this case, we had log base 2 of 4 times x plus 5, which you can rewrite as log base 2 of 4 plus log base 2 of x plus 5. You can't do anything with the x plus 5 term, but log base 2 of 4 is 2 because 2 squared is 4. Let's look at a quotient property. We have log base a of x over y, and with the quotient property, you're going to subtract the logs. So this proof would be very similar to what we did on the last one. So I'm going to bypass that for now and just do an example. So we have log base 10 of 10 squared over 10 to the fifth. Using the property, you would rewrite that as log base 10 of 10 squared minus log base 10 of 10 to the fifth. Checking your answer on the left side, you would subtract the exponents because your two base 10s are divided. So you get negative 3 in the exponent, which means that when you evaluate the log in base 10, you get negative 3. And on the other side, you would have a 2 minus 5, which is also negative 3. Let's try another example. Suppose we had log base 5 of 125 over 625. That would equal log base 5 of 125 minus log base 5 of 625. Well, 5 to the third is 125, and 5 to the fourth is 625. So we would get out negative 1. Another example using the quotient property. We have log base 5 of 3,125x over 5y. Expanding it out, we have log base 5 of 3,125 plus log base 5 of x because they were multiplied, so we would add them. And then the 5 is divided into the 3125, so we would subtract. And the y is also divided, so we would subtract that one. Then the ones that have constants, you want to simplify them. So 5 to the fifth is 3125, and 5 to the first is 5. So we have a 5 and a negative 1 that we can combine, and we get 4 plus log base 5 of x minus log base 5 of y. For the power property, you're going to bring the exponent in front. So where we had x to the n, we're going to rewrite that as n times log base a of x. So if you have log base 2 of 2 to the fifth, that would be the same as 5 times log base 2 of 2 using the property. Well, log base 2 of 2 to the 5th is 5. And log base 2 of 2 is 1. So you just get 5 times 1. So you can see that this property is working. Suppose we had log base 5 of x to the 10th over y cubed. We're going to use a combination of the power property and the quotient property. So we have 10 log base 5 of x using the power property, and then subtracting the log base 5 of y cubed, and then bringing the 3 in front using the power property. So we have 10 log base 5 of x minus 3 log base 5 of y. For our next example, we have the square root as 64x over 9y to the 4th. So I'm going to simplify first, and I get 8 square roots of x over 3y squared. Then expanding it out, whatever's in the numerator is going to have a positive sign in front of it, and whatever's in the denominator is going to have a negative sign in front of it. Now I also use the power property to bring the exponents in front. So where you have x square rooted, you can think of that as x to the 1/2. So your power is 1/2. The next one that we're going to talk about is the change of base theorem. This one's pretty handy when you're trying to evaluate logs, because usually on your calculators you only have log base 10 or log base e, and you can do it in either base. So let's prove this one. We're going to let y equal log base a of x and rewrite exponentially. So we have a to the y equals x. Then I took the natural log of both sides, so I have the natural log of a to the y equals the natural log of x. Then using the power property, I brought the exponent in front, so I have y times log base a, log base e of a. Then to isolate y, I'm going to divide both sides by log base e of a. So I have log of x over log a. And then just putting back in what y is equal to from the very first step, I have log base a of x equals the natural log of x over the natural log of a. It's a pretty easy formula to remember. Whatever is your subscript is going to go in the denominator. So let's use this change of base theorem. So we have log base 3 of 15. You can rewrite that as a natural log of 15 over the natural log of 3, and then put that in your calculator, and you get approximately 2.465. The more decimals you take it out to, the better it is. And we can always check our work, because that means that 3 to that power is approximately 15. So you can check it on your calculator. You can do this in any base you want. It doesn't have to be natural log. It could be common log. It's just that we're choosing those because that's what we have on our calculators. You could do this in log base 5 if you wanted to. Okay. So you have log of 5 in base 10 over log of 8 in base 10, and you get 0.774. And if you take 8 and you put it to that power, you get approximately 5. It'll be a little bit off because these are all rounded numbers. All right, thank you for tuning in to Demystifying Math.